Good evening to all. Yesterday we started with the basics of the electronics concepts, what is electronics and a few of the electronic components and all. So as we were discussing, the electronics is the branch of engineering that deals with study of behavior of electrons in the gases, vacuum and the semiconductors. So semiconductors play a very important role in electronics. So electronics is completely made of the semiconductor technology, as we know. Uh, then we discuss the analog systems and digital systems. The analog systems will receive the information in the analog form, that is a continuous signal, and digital systems will receive the information in the discrete level, that is the high voltage and low voltage, that is the ones and zeros, which is the binary language that all the systems or the computers will follow. These are the electronic circuits. Whenever we say the electronic circuits, the electronic components like the resistors, capacitors, and all. Strictly speaking, the resistors, capacitors, and inductors are not the electronic components, because as we discussed in the last class, the electronics in the sense, the semiconductor must be there. Okay, but we can create or the fabricate the capacitors and resistors in the IC. That is the silicon, the wafer in the using the IC technology. So if it is in IC, we can say it is the electronic components. Otherwise, we'll have to say the electrical component. We discussed the bit about the computer, which is having the CPU and IO ports will be there, so we can connect the input device and output devices through the ports. Okay, and the arithmetic and logical unit. Most of the instructions or the are nothing but the processes done by the CPU are what the arithmetic operations or the logical operations. The arithmetic operations are nothing but the addition, subtraction, multiplication, division, and all. And the logical operations are the and, or, not, and so on. And the memory device will be the part of it. These are the different type of registers we discussed, and also the color coding of the registers. Okay, and we discussed the some concepts of the analog circuit and the digital circuits. The main agenda of this the webinar come the workshop series is what the simulation of the electronic circuits and the microcontroller circuits. So in the beginning, let us see the simulation of the analog circuits, and then digital circuits, and then we go for the Arduino microcontroller, which is the important part of this webinar series. Okay, let's spend more time on the microcontroller interfacing and the projects using the Arduino boards. So yesterday we discussed the analog circuits, that is the Ohm's law. Okay, so we can build a circuit for Ohm's law, and we can apply the voltage using the virtual components. Okay, yesterday we were discussing the simulation software in the virtual lab. Okay, so we can use the virtual components and we can build the circuit diagram, and we can do the experiments as we do in the lab itself. Okay, here you can see the first circuit is what the Ohm's law. So as all of us know, the Ohm's law is what it states: the current flowing through a conductor is directly proportional to the potential difference or the voltage applied across its ends. So here this is the resistor. So resistor also a conductor, because the conductor in the sense it doesn't mean that it is having the zero resistance. all the conductors will have the resistors, or all the devices will have the resistance. So we can call them as the basically a register. So we use instead of the load in the lab, so we cannot use the real load all the time. So we use the registers for the experimental purpose. Actually, the load resistance, or the load in the sense the real devices like fans and all, okay, refrigerator and all, those are called what, say for example, TV, radio, whatever it is. The device we call it as load, but in the lab, we use the resistance boxes or the potentiometers or fixed resistors to do the experiments. Now here, the battery, okay, and or the RPS. This is an ammeter. This is a voltmeter. So as you know, the ammeter is in series with the register. Okay. So on the right side, the circuit shows what it is a Tinkercad, as I was telling yesterday. Here there are some different simulation softwares are there, but here we're going to discuss the Tinkercad. Okay, using this Tinkercad, you can build a lot of 3D animations and all, and also the electronic circuits and all. But we are going to restrict our uh, the session for the electronics circuits, which is our main the objective. Now this the Tinkercad is the open source software. You need not to download it. Just you have to log in through the Chrome or any the browser, and you should work online only. Okay, so we can't work offline, so it should be the online itself. Now the another circuit also we discussed in the last class, that is yesterday. Uh, the diode, the characteristics. So as we know, the diode is a semiconductor, the device. It is having the P type and the N type, the semiconductors. The P type is called the anode, and the N type is also called as cathode. So this is the diode. Okay. This is the diode, and it has a silver ring. I think most of you know, but if anyone is don't know, just see the silver line. That is the N type, and this end is what the P type. So we can connect the diode either in forward bias or reverse bias. The forward bias means the P type. This P type should be connected to the positive, and the N type should be connected to the negative. Okay, the P type should be connected to positive, N type should be connected to the negative. That's called the forward bias. But we are going to use a resistor, which is the current limiting resistor, and this is an ammeter. This actually these two are the multimeters. So we are using this multimeter as the ammeter, and this multimeter as the voltmeter. So we have to take care of the polarities also. The positive, since we are going to connect the DC source here, so we have to connect the positive side of all the DC. We have to use the DC motors of DC meters, of course. Okay, DC voltmeter and DC ammeter we have to use. So we have to take care of the positive terminal of the meters. The positive side of the meters should be connected to towards the positive of the power supply. Okay, so you can see this is the positive of the power supply. It is connected to the positive of the ammeter, and the negative should be connected to the one end of the register, and the other end is connected to the P type. So the P type is connected to the positive of the power supply through this register and the millimeter in series with that. And this N type is connected to the negative of the power supply. Okay. And this is the voltmeter. Since this is the positive term of the power supply, this end, this diode is, the terminals are very important. So this side is the higher potential, the other end is what, the lower potential. So of the power supply. Therefore, this side should be positive. You can see it is a reversed. The positive red is positive, as we know. So we can rotate this multimeter, but it becomes what, the upside down. The readings will be the upside down. So it is connected like this. That is fine. So These are the readings. You can observe now for a small change in the voltage across the diode, there will be large change. So in the previous slide, say here, the voltage across the diode is what? Just, sorry, voltage across the diode is what? 200 millivolts. If you convert it into voltage, it is what? 0.2 volts. Okay, it is a 0.2 volts. When it is 0.2 volts, there is no current. Okay. So when it is a 0.2 volts, no current. That is, current is zero, you can say. Okay, and next slide. So 0.39, there is a 399 millivolts, but the current is also zero. Okay. Next, 0.57 it is a 527 millivolt, 0.527 volts. So the small amount of the current, this is in microampere, 733 microampere. If you convert into milliampere, it is 0.733 million. Very small amount of the current is going to flow. In the next slide is a 0.558 volts. It is a 2.42 milliampere. So little more than the previous current was in microampere, but it is in milliampere. In the next slide, again 0.599 volts, that is a 599 millivolts. So it is what? 12 milliampere. So for a small change in the voltage across the diode, so not this applied voltage, okay, this applied voltage is going to drop across this resistor as well as this diode. So this diode, as we know, when the diode is made forward biased, it starts conducting when it is made the forward bias. Okay, after the knee voltage, it starts conducting. So we know the knee voltage is what? It is 0.7 volts for silicon diode and 0.3 volt for germanium diode. Okay, the knee voltage, you can define it as it is a forward voltage across the diode at which it starts conducting. In a simple way, we say. Okay, so if you reverse this diode, that is called reverse bias. In the sense, the N type is connected to positive and the P type is connected to the negative. That is called what? The reverse bias. If the diode is made reverse biased, so current will not flow. Means it allows the current to flow through it. If you remove this resistor, okay, if you apply the AC here, okay, you can apply the DC or AC. If you remove this resistor, sorry, if you remove this diode, if you apply DC, always the current flows in a single direction, not a problem. But if you apply the AC, the current start to flow on either direction if only the resistor is there. But if we include a diode in series with the resistor, the current starts to flow only in one direction. Okay, that is when the diode is forward biased. Okay, when P type is positive and N type is the negative. Only during that time the current flows. So this is the main property of the diode, which makes it as a it is useful in the rectifier. So we know the rectifier is a device which converts the AC into DC. That is the alternating current into the direct current. In most of the appliances at home, we are going to use the DC only, but not the AC. Therefore, all the devices like refrigerator, TV, radio, and all, so are using only the DC, okay, but not AC. But inside all of those, there will be rectifier, because directly we connect them to the AC power supply, but inside there will be a step down transformer. There is 230 volts will be converted lowered down depending on the device we use, like the 12 volts, 9 volts, 6 volts, and all. Okay, once it is lowered, it is going to be converted into DC using the rectifier, which uses the diode. There are different rectifiers are there, like half rectifier and full rectifiers. In full rectifiers, two types. There is half centered full rectifier and bridge rectifier. In most of the applications, we use the bridge rectifier. Okay, so those are the different the applications of the diode. That's fine. Now let us see. I try to use the Tinkercad. Okay. In Tinkercad, directly we can build these circuits, and we can simulate. That is, we can apply the voltage and see the readings there. Okay. So let's start with the Ohm's law and these two. Let's do these two experiments in Tinkercad. Stop this now. Let's share another screen. Yeah, this is uh, the browser. Directly you can type here the Tinkercad. So it is already I logged in. So in the beginning, if you type it, it will ask the all the details. So log in through Gmail or something. It will ask. Just you have to log in using any of your the Gmail account. So it will enter in this way. You can see here left side, 3D designs are there, circuit code blocks and so on. So we can here we are going to use only the circuits. So if you click on the circuits, so these are all the circuits you'll see. See the home page. Here we are going to design all the circuits. Whatever you have designed will be here. Okay. So if you want to design a new circuit, just to click it on create a new circuit. This is an important part. Just you all of you observe this. Okay, this is the workspace, what we call it as. This is empty space, which is the left side is what the workspace. On the right side, you will see the different components. We have the registers, LED, potentiometer, switch, the battery, audio, and different kind of motors and
Hello, sorry,
sensors,
sir.
and all will be there. So,
Hello, I have
hello,
doubt, sir. Hello,
yeah,
sir. Sorry to interrupt, sir.
yeah,
Sir, can I run this Tinkercad app on my mobile, sir? Because
yeah.
I don't have any
You
laptop
can,
and desktop.
you can, but the screen it will be very difficult to select the components and all. Okay,
Okay,
so better to have to practice it in either tab or
laptop.
laptop or the system. That is better. You try it, but it is very small to select the components in the mobile screen because it is very small. Okay,
Okay, sir. Thank you, sir.
yeah, fine, fine. Now I'll show one circuit to build it here. uh, let's use the same. This is the register. Just click on the mouse and drag it and keep it in the space. Just click other side so that selection will go. If you click on this component, so it will show its parameter. So you can give the name for it, like R1 and all. So I'll give it as R1. If only one register, simply R is enough there. Okay. And what should be the value of the resistance? You have to select it. Say you can see here by default it is what 1, it is there. On the right side is what kilo ohm, so it is 1 kilo ohm. So if you want to change it as say 100 ohm, so you can just type it as 100 here. It is a kilo ohm on the right side, so it accordingly you can see left side the color coding will be selected. Okay, so you need not to select it. Now let's make it as ohm. So it is what? So it is 100 ohm. You can see accordingly, the color coding is also going to change. The color coding for the 100 ohm is what? The brown, black, brown. Brown is 1, black is 0, and third band is the multiplier, which is the 10 to the power 1. It is nothing but 1, 0 into 10 to the power 1. It is nothing but 10 into 10 to the power 1, which is 100 ohm. Okay, so we can select the 1 kilo ohm or 2 kilo ohm, anything is fine. So I'll make it as just go for kilo ohm here. See, automatically the color coding is going to change. So what is the color code for the 1 kilo ohm? 1 means it is a brown. The first band should be the first band. The second digit is what? Black, which is 0. 1, 0. Third one is the red. Red is what? The digit corresponding to the red is what? 2. 10 to the power 2. So it is what? 1, 0 into 10 to the power 2. 1, 0 means 10 into 10 to the power 2. 10 to the power 2 is what? 100. So 10 into 100 is what? 1000. 1000 ohm is nothing but 1 kilo ohm. Okay, fine. So you can rotate this. Just click on this. If you want to rotate horizontal way in the left corner, okay, just to click on this. In clockwise, it will rotate. Okay. So now it is what is a horizontal direction. Okay. Now let's take the power supply. Just to just power you right. It show the different the power supplies and the related. So just to bring it here, and we need a multimeter. There is a voltmeter. Voltmeter is not there. We have to use the multimeter as the voltmeter, or as well as millimeter. So this is if you click on this, you'll see it. There is a multimeter. The name is what? R1. And what about the range? Whether you have to use it as a voltmeter or millimeter, it shows that. Okay. Now, I will give the name for this as A because I want to use it as a, or you can give ME also. It is the millimeter. Okay, or simply a meter is enough. Now you have to give the range here. You can use the multimeter. As we know, the multimeter can be used for the various applications to measure like voltage, current and resistance and all. So if you want to measure the current, you have to give it as the ampere range. And if you want to use the voltage, if you want to measure the resistance, that is the resistance range you have to select. Okay, here the ammeter. And if you want another multimeter, just you click the same, copy it, Control C works here, and Control V, that also works. Okay, now let's use this as the ammeter. That is just I give it as A, and this is should be what? The voltmeter. Let's give the name as what? V, and change the range what? The voltage. Okay, so this is the voltmeter, and this is what? The ammeter. So we can just change it as A. Okay. Now we have to wire this. Okay, let's use.
Excuse me.
Hello, ma'am.
Yes, sir. Sir, excuse me.
Sir,
Sir, can we use this in a Skylab instead of using Genius?
Sorry, ma'am.
Can we use this in Skylab?
Yeah, that is another simulation tool. That's fine. But here we are discussing the Tinkercad, ma'am. A circuit mode is also there.
Actually, Tinkercad I need to install.
No need, ma'am. No need to install. Directly we should log in. Online? Yeah, it is online only.
Okay. Thank you, sir.
You need not to install this. Okay. And in circuit mode, also in other some of the simulators, we cannot simulate the microcontroller circuits. But here we can simulate the microcontroller also. So that's why we are discussing this. Thank you. Now,
sir, can you please repeat?
just you click this and use the leave the mouse, and again connect this. So once the
Excuse me,
connection is
sir.
done, it will show it will be highlighted. Just to leave
Excuse
there
me,
and
sir.
click on that. So this will be connected. So you can change the color of the wire also. Just to click on this. Since I have connected this to the positive terminal of the power supply, so let's use the red in color. So usually for the power supply, we use the red. It is not mandatory, as we know. Let's use the red wire for this. And for this,
Sir,
we
can
can
you
use.
please?
Yes, please, ma'am. Madam. Okay, fine. Now I'll take the another connection here, this side. Just leave it and again start the right side. Leave the mouse and again drag on the right side. Just it will be highlighted. Just click on that. It will be connected. Okay. So next again, I will drag it here and leave the mouse and again hold the mouse and drag down. Again leave it like this. So if you I think you'll find a bit difficult in one or two circuits. Later it will be very easy for you. Okay, fine. So for this wire, just I'll select the black wire because it is connected to the negative of the power supply. Just the black. So the other side, it may be any colors, doesn't matter at all. So now this is, you can see the positive of the power supply is connected to positive of the millimeter. The negative of the millimeter is connected to one end of the resistor, and the other end of the resistor is connected to the negative terminal of the power supply. Okay. Now let us connect this. This is the voltmeter. So multimeter we are using is as a voltmeter. This positive should be connected to this side. Okay, and this negative should be connected to the other side of the register. Okay. You can click on this multimeters. You can make a bit straight according to your convenience. Okay, fine. Now just I'll make it as red in color because most of the uh, voltmeter I am going to connect. I'll use it as the black for convenience. Okay, now the circuit connection is over. Now if you click on these each and every component, you'll find its parameters. Okay, so this is the power supply. So by default it will be 5 volts. You can change its value, say for example 2 volts. Okay, now there is no code. We are not writing any program for this and all. Directly we can go for the simulation. Okay, so click on the simulation. You can see this is 2 volts now. The resistance value is what? 1 kilo ohm. This, whatever we apply the power supply voltage will drop across this resistor because this millimeter will be having negligible resistance. So all the voltage will drop across this resistor. So this is the current. It is a 2 milliampere. So I is equal to V by R. V is what? 2 volts and R is what? 1 kilo ohm. 2 volts divided by 1 kilo ohm is nothing but what? 2 milliampere. So that is what it is going to show. Now, if I change the value for 3 volts, so 3 volts, 3 milliampere. So since the resistance value is 1 kilo ohm, it is very easy to calculate for us. So now I'll try to change the resistance value. Stop the simulation. Just to click on the resistor value, let's make it as the 100 ohm. I'll make it as the 100 ohm. Okay. Now let's apply the voltage, say for example 2 volts. Okay. Start the simulation. So this is the 2 volts now, which is going to drop across the resistor. So from Ohm's law again, I is equal to V by R. V is 2 volts, 2 by the 100 ohm. 2 volts divided by 100 ohm. So it gives what? 20 milliampere. That is a 0.020 ampere is nothing but 20 milliampere. So like this, we can take the readings. Hope you understood how to set the components on the right side of the list of the components in the Tinkercad and drag them and wire them. Okay, now we'll see the one more the circuit, that is a Kirchhoff's current law. Okay, so once you finish this, just you click. This is the left side. You can see this Tinkercad is written with the colors later, different color letters. Just you click on this, and one more thing, the left at the top corner, some random name will be there. Okay, automatically some name will be printed there. So you can just you click on that. You can give the any name according to you. Say for example, I'll give it as the Ohm's law. Oh, Ohm's. I can give your name. Actually, it is already one circuit is there on Ohm's law, so I'll make it as a different name as 2 Ohm's law 2. Just I'll give. Okay, just to click on other side. It takes a small amount of time to change. Yes, now you can see the Ohm's law 2 by Dr. Maltesh. So you can change your name, okay, or any names you can give. Now the one less than 1 minute is there. I request all of you to join once again, okay, with the same ID and password, please, because we are using it Zoom's the free version, so it will be available only for 40 minutes. So I request all of you to join again with the same ID and password.